Bright Duty. Every student matters.
The first chemical property is reaction with metals. When you take a metal and react it with an acid, H2SO4 for example we have taken here, it forms a salt and releases hydrogen gas in the environment. So this can be asked in form of an activity from examination point of view. You will be asked to react these two substances in a beaker and you can attach the tube through a soapy solution, so you'll have bubbles of the gas coming out. Now in front of the gas, like we have discussed previously also, to detect hydrogen gas, we need to bring a burning matchstick near the bubble or near the end where gas is being released, and the matchstick will go off with a popping sound. That indicates that hydrogen gas is released. All the acids react with metal to show this reaction. Bases also react with metal, but not always. Sodium is a very reactive metal like we discussed previously. So sodium does react and it forms a salt, sodium zincate. Sodium zincate is a compound which is a salt, and like I said, not all metals not all bases form this kind of reaction. Moving on to the next property, reaction with carbonate and hydrogen carbonate. So carbonates are compounds which have CO3 in the end, and hydrogen carbonates have HCO3 in the end. These compounds react with acids but do not react with base. For example, Na2CO3, which is sodium carbonate, reacts with HCl to form a salt, NaCl, plus water plus carbon dioxide. Similar reaction is shown by sodium bicarbonate or sodium hydrogen carbonate. So they release carbon dioxide gas and water and form a salt. This is the reaction of carbonate and hydrogen carbonate with acid. This reaction will be better understood when we study the application of these compounds in the third part of the reactions. The third chemical property is reaction with oxides. Now oxides can be formed with the metal or with the non-metal. When they are formed with the metal, like in case CuO, copper and oxide, cupric oxide is a metallic oxide. When it is formed with a non-metal like carbon, then it is called as a non-metallic oxide. So all metallic oxides react with acids. Metallic oxides and acid form a salt and water. Okay. Now the non-metallic oxides don't always react with the bases, but some of them do. This particular reaction is very, very important from examination point of view. Calcium hydroxide reacts with carbon dioxide to form now this compound, calcium hydroxide, we studied this in previous chapter as well. Calcium hydroxide is called as slake lime, and when mixed in, made into a solution, it is called as lime water. So in examination, you can be asked a question like, lime water or slake lime is passed with carbon dioxide and it turns milky. Why does that happen? That happens because calcium carbonate is being formed and calcium carbonate is not soluble in water. You can see chalk. Have you seen chalk? So chalky powder is actually calcium carbonate. The chalk doesn't dissolve in water, so similarly calcium carbonate is settled and that is why the solution turns milky. But if you pass more excessive amount of carbon dioxide, the calcium carbonate also changes. To form calcium bicarbonate. So now this compound is soluble in water and that is why the solution turns back to a clear solution from the milky solution. So the question they can ask you is that slake lime was passed with carbon dioxide, why does it turn milky? It turns milky because calcium carbonate is being formed. When excessive carbon dioxide gas is being passed with, then why does it turn back to a clear solution? That is because calcium hydroxide is formed, which is soluble in water, and so the milkiness disappears. This, as I said, is important from examination point of view. They can ask you the observations, they can ask you the reasons, and they can even ask you to identify the substance. So they can give you an X here, that the substance X was passed with carbon dioxide and the solution turned milky. Identify the substance X. That would be calcium hydroxide. We'll study more types of questions later on. Next is reaction with each other. So acids and bases react with each other to form the third important compound, which are salts. This reaction is called as neutralization reaction. Why is that? Because acids and bases neutralize each other's properties and a neutral substance is formed. Acid was acidic, base was basic, and a neutral substance, salt, is formed when they react with each other. Acid and base react to form salt and water always. This is a very common example. NaOH plus HCl forms NaCl plus H2O. NaCl, as we know, is common salt. The white salt that is available at your homes is NaCl. So these compounds, salts, are formed by neutralization reaction of acid and base reacting with each other. We will study its more applications later on. But for now, you need to know that they are not acidic in nature, neither are they basic. They have a neutral nature, and that is why this reaction is called as neutralization reaction.